Okay guys, in this video we are going to try to make sense of several things that we have done in our previous video, which is the finite integration. So we are going to see what is actually the thing that you have done, right, graphically, right? We are going to look at the function of 2 cos x plus 3 sin 4x, right, in the exercise of the finite integration. Okay, when you look at the function graphically, this is how it looks like. This is the graph for the function 2 cos x plus 3 sin 4x, right? We are going to leave on how to create this graph on the next occasion. Okay, I'm just going to not tell you what really happened when you want to find an area for this graph. So basically, when we conduct an integration for this function or this graph, it literally means that when they give you an upper and lower bound, right, what they want is they want you to find the area under the curve that actually within that bound. So let's see, in our case before, the bound is negative pi over 2 to pi over 2, right? So negative pi over 2, if we try to put it in the form of figure, it will be around 1.57, negative 1.57, right? Which is this will be the lower bound for this for that question. And we also have the upper bound, which is pi over 2, right? The positive side of the same value. In other words, this is the area that they want us to find the value, right? We have quite some space here where actually the area that we need to look at. Again, for integration, we talk about area under the curve. So we have these curves within these bounds. So area under this curve is this, right? We have this hill-like curve here. As for this one, even though, as I described before, even though we are saying under the curve, under supposed to be at the bottom, but then because for the case of negative, it is actually above the curve, because under the curve is actually in terms of x-axis. So for this one, because it is under the x-axis, so basically this is the area they want to look at. And the same goes for the one, this is the area they want to look at. And as for this one, because it is negative, this is the area they want to look at, right? So when we conduct a definite integration, okay, we do the calculation, right? Basically that is the area that we are looking at. Look at the highlighted area there, and we did get 4, right? So 3.9 and something, it is 4. However, there is one thing that I want to emphasize here. Value 4 here is not really the total area of these 4 highlighted areas. It is not, okay? Because for these 2 areas that is below the x-axis, the total area will be in negative, right? So when you sum all of them, it will cancel out this area. So it will actually sum, subtract. So 4 here can be said as their net area, right? Net area, not the total area, right? So basically, if you want to consider taking these two area include in your total value of this area later, you should do it manually, right? You cannot just calculate them in one go, which is from negative to positive, and you'll get the value 4. That will not do. You will need to calculate one by one, range by range, so that you can sum them manually later. Right? By integration, you can't really get the total area if you have the area that is in the negative quadrant like this. All right. So basically, that is what happened in the finite integration, right? Where we actually finding this area, right? This is the area that we calculate before, right? The highlighted area there. All right. Now, the second thing that I want you to be clear on is actually on the even function. Right? I did say in a previous video that even function is a function in trigonometry, is applicable to cosine and secant. Now we have several basic trigonometric function, right? We have tan, sine, cos, cotangent, cosecant, secant, right? However, only cotangent, cosine and secant are considered as an even function. Let us see why. All right. So this is cosine. This is the graph of cosine. As you can see, in terms of area, okay, in terms of area, this is the y-axis, and you have the negative area x-axis on the left side and the positive x-axis on the right side. In terms of area, right, it doesn't really matter the value is on the left side or on the right side. They will give you the same area, right? As you can see, it is symmetry, right? It is symmetry. The same goes for secant, right? Where the graph of secant that is looking like this, as you can see, it is also symmetry in terms of if you compare it with y-axis. So this is what is known as even function, where you have an even area in the positive and negative x-axis. So because of that, it doesn't really matter if your x that you substituted in the function positive or negative, right? You just make it positive because they will give the same area. Let's look at other functions. All right, let's start with sine. This is the graph of sine. As you can see, try to look at y and compare it left and right, and you'll see that they are actually inverse from each other. So if let's say you try to find an area from -3 to 3, you are going to see that they will be cancelling out each other, because this one they are in a negative area and this is on a positive area. In other words, they are inverse from each other. They are not even function. The same goes for tan. Right? If you like to look at this. The area for under the curve for tan is this, as in a positive area. However, in negative area they are inverse. and cotangent, we can say the same thing, right? And then cosecant, right? This is even, you know, not inverse and not even. They are totally different. Okay, so that is what I meant by even function, right? So that's it for this video. Thank you.